collision. Collision meaning when two particles approaches each other, their mutual interaction changes their motion is continuously and their momentum are changed. This is called collision. When two particles, consider two particles of mass m1 and this is mass m2. Consider two objects. Consider polarity particles of mass m1 moving with velocity u1 and consider another mass m2 moving with velocity u2. This is kinetic energy is conserved and linear momentum is also conserved. The loss of kinetic is m2 v2 square minus u2 square. This is equation from 2. This is equation from 2. From equation next. Next, this is equation from 2. This is the energy equations. This is kinetic energy equation. Okay. This is equation from 2. From dividing equation, this is the rearranging the equations. This is m1 half u1 square minus half m1 v1 square. This is this is equation, sorry, this is equation number 1, this is equation number 2. This is energy equation, this is the from law of conservation of momentum. Okay, next dividing equation, dividing equation 2 by 1. This is a dividing equation 2 by 1. This is equation number 2. m1 u1 square minus v1 square divided by, this is m1 u1 minus v1. This is equal to m2 v2 square minus u2 square divided by, this is m2 v2 minus u2. This is a square minus b square, where a square minus b square equal to a plus b into a minus b. Okay, this is m1 split in the u1 square minus v1 square. This is u1 minus v1 into u1 plus v1 equal divided by m1 u1 minus v1. Same also in the right side, m2 v2 minus u2 plus u2 divided by m2 v2 minus u2. This numerator and denominator both sides are m1 cancel each other. This is u1 minus v1 is also cancelled. Okay, remaining equation u1 plus v1 equal to v2 plus, okay, this is rearranging equation u1 minus u2. This is v2 minus v1. This is equation number 3. This is u1 minus u2 equal to v2 minus v1. This is the relative velocity of approach, the approach before collision, and relative velocity of separation after the collision. This is relative velocity of approach after collision u1 minus u2, and the relative velocity of separation v2 minus v1. This is the after the collision. For an elastic collision in one dimensional, the velocity of approach of the two particles before collision, and the relative velocity of separation of the two particles. Okay, for an elastic collision in one dimensional, the relative velocity of approach before collision is equal to the relative velocity of separation after collision. Okay, this is the u1 minus u2 equal to v2 minus v1. Next, continuing the substituting v2 equal to u1 minus u2 plus v1. This is v2. V2 minus U, V2 minus U. This is equation number 1. This is the law of conservation of momentum. Okay, this is V2 equal to U1 minus U2 plus V1. Substituting in equation number 1. Substituting V2 in equation number 1. Okay, equation number 1. This is M1 U1 minus V1 equal to M2. This is V2 is same. U2 equal to U1 minus U2. This is plus V1 plus V1. Okay, M1 U1 minus M1 V1. This is M2. Sorry. V2 minus U. Sorry. V1. Sorry. This is U1 minus U2. Plus V1. This is M1 V1. This is M1 V1 plus M2 V2 equal to M1 V1 plus M2 V2. This is M1 is common. U1 minus V1 equal to M2 V2 minus U. Okay, this is M1 U1 minus V1 equal to M2. This is V2 equal to U1 minus U2 plus V1 minus U. Sorry. This is M1 U1 minus V1 equal to M2. This is U1. This is minus 2 U2. This is plus V1. Okay. M1 U1 minus M1 V1 equal to M2 U1 minus 2 M2 U2 plus M2 V1. Okay, this is rearranging in the equation. M1 V1. This is minus M2 U1 plus 2 M2 U2 equal to M2 V1. This is plus M1 V1. This is common in the U1. This is M1 minus M2. M1 minus M2 plus M2 to M2 U2 equal to, this is common in V1. This is M1 plus, sorry, M2 plus M1. Okay, this is equation in the substituting V2 in equation number 1. This is equation number 1. Okay, next continuing equation. Okay, this is V1 equal to V1 equal to V1 equal to V1 equal to U1 M1 minus M2 divided by M1 plus M2 plus 2 M2 divided by M1 plus M2 to V. This is equation V1. Next, u1 plus, okay, this is u1 minus v2, this is plus v1, this is v2, this is v1 equal to v2, this is minus u1 plus v2. Okay, this is right side, it is okay, v1 equal to v2 minus v2 minus v1 plus u2. This is substitute same also from equation number 1. m1, this is u1 from equation number from equation number 2. This is m1 u1 minus v1, this is m2 v2 minus u. Okay, this is substituting v1 in equation number, this is equation number 2. This is m1, this is v1 u1 in terms, this is v1 equal to v2 minus u1 plus u equal to m2 v2 minus u. Okay, continuous. Okay, this is m1 u1, this is minus, this is v2 minus v2 minus v2 minus into minus plus u1 plus into minus minus u. Okay, equal to m2 v2 minus u. Okay, this is for substituting v1 in equation number 2. This is m1, this is u1 plus u1, this is 2 u1 minus v2 plus minus 2, this is 2 u1 minus v2 minus u2. Okay, equal to m2 v2 minus u. Okay, this is 2m1 u1 minus m1 v2, this is minus m1 u2. Okay, this is next m2 v2 minus m2 u. Rearrange the equations. This is minus u1 2m1 u1. Okay, this is my m1 u2. Okay, this is plus m2 u2. Okay, equal to m2 v2, this is plus m1 v2 v2. This is common. This is 2m1 u1. Okay, this is common minus u2, this is m1 minus m2. Okay, equal to v2, this is m1 plus m2. Okay, okay, this is